All right, looking at some indifference identities for sine and cosine. We're starting with the question, does cosine of 30 degrees plus 60 degrees equal cosine of 30 degrees plus cosine of 60 degrees? All right, so let's work on this, see if we can figure it out. 30 plus 60 is 90. So the left side is cosine of 90 degrees, and we know from the unit circle that cosine of 90 degrees equals 0. On the right side, cosine of 30 degrees from the unit circle is square root of 3 over 2. Cosine of 60 degrees is 1/2. We have a common denominator of 2 here. So we have square root of 3 plus 1 divided by 2. Square root of 3 is about 1.7. So 1.7 plus 1, 2.7 divided by 2 is about 1.3. Clearly not equal to 0. So the answer here is a big fat no. They're not equal. So what this tells us is that we can't just distribute cosine when we're adding two angles like this. It's not distributive. Cosine's not distributive, sine's not distributive, and as we'll see tomorrow, tangent's not either. So, in place of that, when we have sine of adding or subtracting two angles, we use these formulas, sine or cosine. Notice for the sine formulas, sine of a plus b or sine of a minus b, that they both have sine times cosine for the first term, plus or minus cosine times sine. So we're mixing the sines and cosines when we multiply them together up here. For the cosine formulas at the bottom two, a plus b and a minus b, it's cosine cosine minus sine sine, or cosine cosine plus sine sine. So when you see cosines and sines together, we're talking about cosine formulas. When we see sines and cosines mixed, we're talking about sine formulas in general. You do not have to memorize these formulas as long as you know how to use them. That's sufficient. So now we're going to use them. Starting with number 2 here. We've got cosine 3x times cosine of 2x plus sine of 3x times sine of 2x. So hopefully you can see that this is cosines multiplied together plus sines multiplied together, which tells us it's a cosine formula, because we have cosine, cosine, sine, sine, and there's a plus in between, like the plus here. So this is the formula we're going to use right here, this last one, cosine of a minus b. Our a value is 3x, our b value is 2x. So this equals the cosine of a minus b, 3x minus 2x. Well, 3x minus 2x is x, and so all of this will equal cosine of x. All right, cosine of x. Okay, let's look at the next one. Number 3. Sine of 105 degrees, cosine 15 degrees minus cosine 105 degrees, sine 15 degrees. So in this case, my a is 105, my b is 15 degrees. And this time they're mixed, sine cosine minus cosine sine. So it tells me it's one of these sine formulas. And I have a minus in between. So that's going to be formula number 2 right here, sine of a minus b. So this fits the pattern of sine of a minus b. So this is sine of a was 105 degrees minus b is 15 degrees. And 105 minus 15 is 90. And that's actually a unit circle value. Sine of 90 degrees equals 1. When we get unit circle values on these lessons, then we want to go on and simplify them to whatever number we get. If we don't get a unit circle value, for example, if my answer was sine of 32 degrees, I would just leave it as sine of 32 degrees. We don't have to mess with calculators here. All right, let's go to the back. All right, verify the following identity. Cosine of pi plus x equals negative cosine x. So we're going to use the cosine formula here from the front. The cosine formula says, so I'm going to work on the left-hand side. Remember with the cosine formula, here's my a plus b. So cosine a, which is pi, times cosine b, which is x, minus, since it's a plus here, it's a minus here, sine of a, pi, sine of b, x. Well, cosine x and sine x, I don't know what that is, but cosine pi and sine pi from the unit circle, cosine of pi is negative 1, cosine x minus sine of pi is 0 sine x. Negative 1 times cosine x is negative cosine x. 0 times sine x is 0. And negative cosine x minus 0 is negative cosine x, which is exactly what we're trying to find. And so we have verified our identity. All right, last but not least, this one is the trickiest here. Suppose sine of alpha equals 4/5 and sine of theta equals 5/13. Where alpha is between 0 and 90 degrees, theta is between 90 and 180 degrees. Find the value of sine alpha minus theta and cosine of alpha minus theta. Okay, so we have two different angles. We have alpha and we have theta. Alpha is in the first quadrant, theta is in the second quadrant. So let's just kind of draw this out. I've got alpha here in the first quadrant, like that. If I drew a right triangle here, I know that my sine of alpha, remember that sine is always equal to y over r is equal to 4 over 5. So my y value is 4, my r value is 5. And if we did x squared plus y squared equals r squared, we would find x squared plus 4 squared equals 5 squared. Work all that out, we get x squared is equal to 9. And x, since we're in the first quadrant, I know x is positive, so it's going to be a positive 3 here. And my cosine, which I'm going to need, cosine alpha, is equal to x over r 3/5. All right, theta is in the second quadrant. It looks something like that. This was my alpha over here, this is my theta. And sine of theta equals 5/13. Remember, this is, again, y over r. So I'm going to have 5 here and 13 here. And we'll say x squared plus 5 squared equals 13 squared. If you work all this out, you're going to find that x squared is 144. And this time, I know it's going to be negative. Since I'm in the second quadrant, my x value has to be negative. And so my cosine of theta is negative 12/13 since I'm in the second quadrant. Alrighty, now I have everything I need. Let's work this out. Sine of alpha minus theta, from our formulas, a minus b here, this is sine alpha cosine theta minus cosine alpha sine theta. I'll scoot this up just a bit. Alright, so sine alpha was given to us as 4/5. Cosine theta is given to, I figured that out actually, negative 12/13 minus cosine alpha 3/5. Sine theta was given to me 5/13. Do a little simplification, let's multiply, negative 48 over 65, negative 15 over 65. Same signs, I'm just going to add those together and keep it negative. So this is negative 63 over 65. Notice it's still greater than negative 1. Remember that no matter what we're doing with sine and cosine, it will always be between negative 1 and positive 1. If we'd gotten negative 66 over 65, we would think, all right, something's wrong here because there's no way that sine's going to be less than negative 1. All right, so be careful with that. Let's do cosine now. Scoot it up a little bit more. Cosine of alpha minus theta is equal to cosine alpha cosine theta plus sine alpha sine theta. So cosine alpha 3/5, cosine theta negative 12/13, plus sine alpha 4/5, sine theta 5/13, negative 36 over 65, plus 20 over 65 is equal to negative 16 over 65. Okay? If you have questions about anything, let me know. You can also, if you text a classmate or something, maybe they can help you out, or send me an email. Shoot me an email on Schoology. If a lot of people ask the same question, I'll post something to try to clarify as much as I can. I hope this makes sense to you, and I hope you're doing well. Stay safe, and we'll talk to you soon.